Hello everyone, my name is Gemma Rodriguez and today I'm going to present our recent TSC paper, Watch Out for Extrinsic Bugs, a case study of their impact in just-in-time bug prediction models. This work is a collaborative work with Professor Mayapana Capan from the University of Waterloo and Professor Gregorio Robles from the University King Juan Carlos. In our previous study, we identified two types of bugs, intrinsic and extrinsic. Intrinsic bugs are bugs for which a bug-introducing commit can be identified in the version control system, while extrinsic bugs are caused by external changes to a software, such as errors in external APIs or changes in the requirement. So the main difference between intrinsic and extrinsic is that intrinsic bugs have a specific change recorded in the version control system that can be blamed as the bug-introducing change, because the source code lines at that point were buggy. Contrary, extrinsic bugs don't have a specific change in the control version system, so no previous change can be blamed as the bug-introducing commit. In this previous study, we identified that 9 to 21% of the bugs analyzed from two different projects, OpenStack and Elasticsearch, were extrinsic. So the next question was to understand whether extrinsic bugs were important, because so far most of the studies assume that bugs are always intrinsic. For that, we studied the impact of extrinsic bugs in bug prediction. We use this technique because bug prediction learns from characteristics of previous bugs to predict future bugs. Specifically, we focus on just-in-time bug prediction because these models do their predictions at the change level, so they can predict whether a change is likely to be a bug-introducing change or not. For that, the way how just-in-time works is the following. It extracts information from the control version system, the issue tracking system, and the code review system, and creates some metrics for each change. These metrics can be grouped into source code properties such as size, history, review, diffusion, or experience. Then, just-in-time uses a set to identify the bug-introducing changes and also to identify the clean changes. Finally, we build the models and use the past data from training the models and predict whether a change will be a bug-introducing change in the future or not. However, just-in-time assumes that all bugs are intrinsic, so all the bug-introducing changes are linked to intrinsic bugs. However, as we recently saw, this is not always true. Extrinsic bugs don't have a specific bug-introducing change in the control version system. So we want to study what is the impact of removing extrinsic bugs from the training dataset when predicting bug-introducing changes. For that, we partially replicated the work of McIntosh and Kamei, but this time having into account the extrinsic bugs. We started from the dataset in the paper of McIntosh and Kamei. We found it in the reproducibility package, and then we'll link bug reports with bug fix and commits. Then two different raters, myself and a master student, classified the issues according to the original classification of Hersin et al. This is a bug or not. Then, in the cases where we classify the issue as a bug report, we classify whether it was intrinsic or extrinsic following the classification rules that we previously did in our paper. After that, we filter out extrinsic bugs and we use the filters in McIntosh and Kamei study. Finally, we obtain our final dataset and build the just-in-time bug prediction models following the original design decisions from McIntosh and Kamei study. To build the model, we split the data into a series of time periods of 3 and 6 months. Then we train the models using one period and testing in the other periods. Finally, we use short and long period models to train each period. Short period means that we use only one period for training, but long period means that we use that period and the previous one for training. The first result we obtained was the difference between our manually curated dataset and an automatically extracted dataset, as McIntosh and Kamei. We can observe that over 40% of McIntosh and Kamei's dataset are not intrinsic bugs. So an automatically extracted dataset might not be a reliable dataset to train just-in-time models. Then another result is that when removing extrinsic bugs, just-in-time models obtain higher performance in terms of AUC points, up to 16% AUC points of difference. As you can see in the picture, our models in the right side of the slide obtain higher AUC scores when compared to McIntosh and Kamei. This can be seen visually because blue shades or blue boxes means higher AUC scores and white boxes means almost random guessed. As we can see in the picture, our models obtain higher accuracy when using the first periods for training. We also notice that our just-in-time models have considerable differences with the ones from McIntosh and Kamei in terms of the importance of the families of code change properties. We saw that the importance of the size family increases in our study when compared to McIntosh and Kamei, but contrary, the review family decreases when compared to McIntosh and Kamei studies. Here again, blue shades mean higher importance. Finally, we observe that the distribution of extrinsic, intrinsic, and mislabeled bugs have differences, and that the code change properties of bug introducing change linked to extrinsic, intrinsic, and mislabeled bugs are statistically significant different in 5 out of 6 families. So now that we know that bugs can be extrinsic and intrinsic and that extrinsic bugs can impact just-in-time bug prediction models, we can discuss the implications of this study. First of all, we saw the impact of extrinsic bugs in just-in-time models, and we saw that the predictions changed when include these bugs into the training dataset. But this is not the only implication. Another result is that we can have implications in software engineering. We saw that extrinsic and intrinsic bugs have differences, and these differences are statistically significant in terms of code change properties. So at the end, intrinsic and extrinsic bugs might have different review practices. Another implication can be on education. We should educate the students in the fact that software bugs don't always have their origin in a change in the control version system. We also can have implications for data awareness. Developers should be aware of the type of bugs they are fixing and start labeling them. This will be very useful for just-in-time bug prediction and for other purposes. We also can have implications on tools. The development of tools that help in the classification of bugs might be very useful for researchers. Finally, our research, we can have implications on research. The different nature of extrinsic and intrinsic bugs demands a well further research. We believe that previous studies have focused much on intrinsic bugs, but there is a lack of understanding, research, and tools on extrinsic bugs. So finally, to sum up, we saw that this study wants to understand the impact of extrinsic bugs. We saw that 40% of an automatically restricted dataset are not intrinsic bugs, so we cannot have reliable dataset. We saw that extrinsic and extrinsic bugs have different characteristics. We saw that when removing extrinsic bugs, JIT models obtain better performance. And finally, we saw the impact and implications of our findings. So thank you very much for attending to this talk. Bye.
Okay, and we should be live, and welcome to this session. I'm Robert Felt, and I will be the session chair, and the session is titled Defect Prediction, Bug Characterization, and Analysis. And I'm very happy Rodriguez Perez here, one of the authors, who will help us better understand the work. Yeah, I also want to commend you for doing a kind of replication study, which is not so common in software engineering. And you also do it with kind of a refined lens or view of the actual underlying data. So very nice work. I see we have a question in the chat from Aurora. So how much in time did you spend on the manual bug labeling?
So yeah, good question, Aurora. Thank you very much. So it was very time work consuming doing the labeling. Myself and another master students, we did the manual analysis, and I think we spent around 1 month more or less doing the manual analysis, and came in up with the agreement, the ratio agreement, and so on. So I think, yeah, around 1 month or month and a half probably to have the curated data set. Yeah.
So 2 people, 1.5. Let's say 3-person month. And how many bugs did you label again?
Just 1,080, 100. Yeah.
Okay, so that's that's a lot then. It's costly, right? And so I guess you considered if you could automate some of this labeling. And have you tried some of that, or have you considered that?
So we are currently working on TS, and this is something that we would like to do, like automatize the identification of extrinsic bugs. The problem is that you need a lot. So we were thinking on using AI or like machine learning, deep learning, natural language processing, because we found that a lot of the words that for extrinsic bugs were in the commands. But yeah, we don't have like enough data to build and train the model. So probably we will need to go to another way of automatize them.
Yeah. Okay, and we have a question from Leandro, and he thinks this will be a very impactful study, which I think too, so congrats on that. And he's asking about were there any differences in depending on how you train the models, considering only recent data or considering all the data you had?
No. In fact, since this was a replication study, we followed the same methodological decisions as McIntosh and Kamei, and we used their scripts. So in the original paper, they provide everything, and it was amazing. We also get their support during the replication process. So it was even better, and we follow their same decisions. So we didn't change anything on the training, when training the data, or when testing the data.
Okay, so I mean, considering this, so that's very nice to hear that you got support from the original authors. Have you done any replication studies before, and did you find this experience different somehow?
No, this was my first replication study.
Okay.
So yeah, it was, and indeed this wasn't a full replication. This was a partial replication because the original paper has two projects, OpenStack and Qt, but due to the manual analysis and all the hard work that we need to do, we only focus on OpenStack. But no, this was the first replication. But Gregorio, he had experience, so he guided me through the process.
Okay. Yeah, I mean, of course, as a community, we are still learning how to do replication packages and support this, right? So I think it could be very valuable. Also that, kind of on a meta level, this type of study. Oh yeah, so Grigori also kind of mentions Shane McIntosh and JustInTime Kamei. So yeah, they deserve a big thanks. Great.
Yeah.
So the larger question here is, of course, that now you studied this distinction between intrinsic and extrinsic bugs on a particular software engineering task. But it seems to me that this can affect a lot of other sub areas or topics in software engineering. Have you thought about what kind of effect it could be? I mean, have you considered other areas or topics in software engineering where this is very important to consider?
Yeah. So the last part of the paper and the presentation was about the implications, and we consider that one of the impact or implications of our work it's also in software engineering. So probably with the knowledge of extrinsic bugs, professors and the whole community can educate the students and developers and practitioners that not all times the bugs are intrinsic, that we can have like both extrinsic and intrinsic, and we can teach them or educating them on the characteristic of extrinsic bugs. So this was one of the implications also for practitioners. So in the code review practices, this is something that we would like to research more in depth, but in the code review practices, it might happen that extrinsic bugs should be addressed differently when they are reported than intrinsic bugs, and they can have like differences, and this is something that we would like to do. So as I said, I think it will impact like a bigger area than software engineering.
Yeah. What would you say is the sort of the main difficulty in deciding? Is it deciding between a bug being intrinsic or intrinsic or extrinsic, or is it even hard to know if a commit is, because I guess in some sense any change can be a bug and any change can be both an intrinsic or an intrinsic bug. So are there kind of levels to this where some of it is more difficult? So
under my experience, it's not very difficult to distinguish between intrinsic and extrinsic when you read the bug report, and you kind of understand what was happening in the context. What is most difficult, it's understanding at what time in the history of the project, right? Because probably at that time you don't have like the whole context, or you cannot even identify the change that introduced, the external change that introduced the bug, right? So this is the most difficult part, like trying to understand at what point in time.
Okay. And Leandro has refined his question or clarified it. So he was asking if you consider training models on only on the more recent data, or looking on or the whole period, or was this something you considered, or?
No. Since again, since this was a replication, we decided to just go with their decisions. But this can be a really good idea. So we also publish the replications data and the data, so you can try. Yeah.
Okay. Let's see if we have some more questions. Yeah, seems many people are impressed with your hard work. I mean, it's super important to have this type of work, right? So, are you also sharing? Okay, here we found something. Now it's we don't have so much time, but yeah, we probably don't have time for that question now, Stefan. But yeah. Right, we have to consider that maybe in the discussion room, so you can follow.
Okay.
Yeah. So thank you very much, and thanks to everyone for their questions, and to Gemma and Gregorio and the authors, and see you soon.
Thank you very much for all the questions. Bye.
Bye.